Imagine a flat Earth. It sounds simple, right? A vast, endless plain stretching out in all directions, no curves, no edges, just an infinite flat surface. But what if we told you that this seemingly simple idea would lead to some very strange and unexpected consequences? Gravity, the force that keeps us grounded, would act very strangely on a flat Earth. Normally, gravity pulls everything towards the center of the Earth, giving us a sense of up and down. But on a flat Earth, things would be quite different. Instead of pulling towards the center of a spherical Earth, gravity would pull towards the middle of the flat disk. This means that the direction of gravity would change depending on where you are standing on the disk. As you move away from the center of the disk, everything would start to feel heavier, walking would become more difficult, and objects would seem to weigh more. This is because gravity would be pulling you at an angle, making it feel like you are constantly walking uphill. Trees and other plants would grow diagonally, always trying to reach the center of the disk, where gravity is strongest. Forests would look very different, with trees leaning towards the middle instead of growing straight up. Water would behave in a bizarre manner as well. Instead of flowing downhill towards the lowest point, it would rush towards the center of the disk. This would create a giant ocean in the middle, with water constantly flowing inward. People living near the edge of the disk would experience a much weaker gravitational pull. The further you are from the center, the less gravity you would feel. This could make everyday activities like walking and standing quite challenging. In fact, if you got too close to the edge, you might even start to float off the ground. The weak gravitational pull would make it feel like you are in a zero-gravity environment, similar to what astronauts experience in space. Gravity is a fundamental force that shapes our world. It's what keeps our feet firmly planted on the ground and allows us to live our daily lives with a sense of stability and order. Without gravity, life as we know it would be impossible. It's the force that holds everything together, from the smallest particles to the largest galaxies. On a flat Earth, gravity would be a confusing and unpredictable force. Objects would move in strange and unexpected ways, making it difficult to navigate and live a normal life. The quirky consequences of a flat Earth would make life as we know it impossible. Our world is shaped by the forces of nature, and gravity is one of the most important. Without it, everything would fall apart. Now let's talk about the sun. The sun, our closest star, is a massive ball of burning gases that provides the energy necessary for life on Earth. It rises in the east and sets in the west, a pattern that has fascinated humans for millennia. In the flat Earth model, the sun is like a small spotlight. This model suggests that the sun is much closer to the Earth than in the heliocentric model, and it moves in a circular path above the flat surface. It circles above the Earth, illuminating only a portion at a time. This is supposed to explain why we have day and night, as the sun's light only reaches certain areas while leaving others in darkness. However, this explanation creates more questions than answers. For instance, if the sun is a spotlight, why don't we see a sharp edge of light and dark on the ground? And how does this model account for the varying lengths of days and nights throughout the year? How would the sun orbit a flat Earth? The mechanics of such an orbit are not explained in the flat Earth model. Traditional physics and our understanding of gravity don't support this idea. Why don't we have seasons if the Earth is always facing the sun in the same way? In the round Earth model, the tilt of the Earth's axis and its orbit around the sun create the seasons. This tilt causes different parts of the Earth to receive varying amounts of sunlight throughout the year. How does the day-night cycle work with a spotlight sun? The flat Earth model struggles to explain the smooth transition from day to night and the consistent pattern of sunrise and sunset observed worldwide. The flat Earth model doesn't explain eclipses or other celestial events. Eclipses occur due to the alignment of the Earth, Moon, and Sun, which is well explained by the round Earth model. The sun's movement is crucial to our understanding of the universe. Its predictable path and the phenomena it creates, like seasons and eclipses, are all explained by the round Earth model. The flat Earth model oversimplifies this complex relationship. It fails to account for the vast amount of evidence supporting the round Earth theory, from satellite images to the way we experience day and night, seasons, and celestial events. Let's move on to the atmosphere. The atmosphere is the blanket of air that surrounds our planet. It's held in place by Earth's gravity. But on a flat Earth, gravity wouldn't be strong enough to hold the atmosphere. Without gravity, the atmosphere would simply drift off into space. The sky would be black, even during the day, and without air pressure, our bodies would be exposed to the vacuum of space. We need the atmosphere to breathe, to regulate temperature, and to protect us from harmful radiation. A flat Earth without an atmosphere would be a very inhospitable place. Earth has a magnetic field that acts like a shield. It protects us from harmful solar radiation. This magnetic field is generated by the movement of molten iron in Earth's core as it rotates. A flat Earth doesn't have a rotating core. This means it wouldn't have a magnetic field. Without this protective shield, we would be bombarded by radiation from the sun. This radiation would be harmful to all life on Earth. The magnetic field is a crucial part of what makes Earth habitable. A flat Earth lacking this field would be a very different and much more dangerous place. Section 5. Shifting continents on a standstill. In this section, we delve into the fascinating world of plate tectonics, a theory that explains the dynamic nature of our planet's surface. Next, let's consider plate tectonics. This theory revolutionized our understanding of Earth's geology. It proposes that the Earth's outer shell, known as the lithosphere, is divided into several large and small plates that float on the semi-fluid asthenosphere beneath. This is the theory that Earth's outer layer is made up of moving plates. These plates are constantly in motion, albeit at a slow pace, driven by forces such as mantle convection, gravity, and the Earth's rotation. These plates collide, separate, and slide past each other. When they collide, they can form mountain ranges like the Himalayas. When they separate, they create new oceanic crust at mid-ocean ridges. And when they slide past each other, they can cause earthquakes along fault lines like the San Andreas Fault in California. This movement causes earthquakes, volcanoes, and the formation of mountains. The energy released during these events can be immense, reshaping the landscape and affecting life on Earth in profound ways. Plate tectonics relies on the Earth being a sphere. The spherical shape of our planet allows the plates to fit together and move in a coherent manner. The plates fit together like a puzzle on a curved surface. This interlocking nature is crucial for the movement and interaction of the plates. On a flat plane, the plates wouldn't fit together properly. The dynamics of plate movement would be entirely different, and the geological processes we observe would not occur in the same way. There would be no way for them to move and interact in the way that we observe. The interactions between plates are responsible for many of the Earth's geological features and phenomena. Plate tectonics is a fundamental process that shapes our planet. It influences the formation of continents, the creation of ocean basins, and the distribution of earthquakes and volcanoes. It's responsible for the continents, the oceans, and even the air we breathe. The movement of plates affects the carbon cycle, which in turn influences the Earth's climate and atmosphere. A flat Earth simply cannot account for this important geological phenomenon. The theory of plate tectonics is a testament to the complexity and beauty of our dynamic planet, constantly reshaping itself over millions of years. Section 6. Satellites lost in space. Now let's think about satellites. Satellites orbit the Earth, providing us with communication, navigation, and weather forecasting. They rely on Earth's gravity to stay in orbit. On a flat Earth, satellites wouldn't be able to orbit. They would either fly off into space or crash back to Earth. Without satellites, our technology would be severely limited. We depend on satellites for many aspects of modern life. A flat Earth would disrupt these technologies and have a significant impact on our daily lives. Section 7. A different perspective. The shape of the Earth has been studied and confirmed for centuries. We have evidence from ships disappearing hull first over the horizon. We have photographs from space showing a spherical Earth. On a flat Earth, we would be able to see objects much farther away. Shadows would always be the same length, regardless of the time of day, and circumnavigating the globe would be impossible. These are just a few of the many differences between a flat Earth and a round Earth. The evidence overwhelmingly supports a spherical Earth. Section 8. Living on the edge of belief. The idea of a flat Earth might seem intriguing, but it's important to remember that scientific theories are based on evidence. The flat Earth theory lacks this evidence. Believing in a flat Earth often leads to social isolation. People who challenge this belief might be dismissed or ridiculed. This can create divisions and erode trust in scientific institutions. It's okay to question things and be curious, but we should always rely on evidence and critical thinking. The Earth is not flat, and that's a good thing.